Okay, in this video we'll look at the 20, actually don't know what year it is, but it was one of the questions assigned. So a security code consists of 6 digits chosen at random from the digits 0 to 9. The code may begin with a 0 and digits may be repeated. So that's all very important. So you're allowed to have the code 000000, for example. So that'll be okay. So they may be repeated. How many of the possible codes will end with a 0? So I think a good approach to taking a question like this, you've got a 6-digit code. Fill in any restrictions first. So if it must end with a 0, there's only one possible choice for that. So it must end in a 0. It can begin with any one of 10 digits. And digits may be repeated, so all 10 are available. So 10 by 10 by 10 by 10 by 1. Because when you've got digits 0 to 9, that's 10 digits. So multiplying all of that together and you get 100,000, I think. Now, find how many of the possible codes will contain the digits 2018 together and in this order. So basically all 4 of those digits are together and they're in that order. So there's only really 3 potential outcomes. Either these 4 digits could be at the start, just treat them as 1, and then you've 2 more digits at the end. So this is the first 4 digits of your code, but they have to come in that order. So then there will be 10 digits here and 10 digits here. But there's only one choice for that, so that's really just 1. So it's 1 by 10 by 10. Similarly, the 4 digits could be together in the middle. So if the 4 of them were together, there'd only be room for 1 more digit each side because it's a 6-digit code. But in any one of those, you have 10 potential options. You can go 0 to 9. So that would be 10 by 1 by 10. There's only one choice here because that's the one that we're interested in. It has to come in that order, 2018. And then likewise, you could have 2018 at the end and the 2 other digits at the front of it. So there's 10 choices available for each of those. So then that will be 10 by 10 by 1. So this or this or this. So that will be 100 plus 100 plus 100. So 300 possible codes would have 2018 together. Now find A, B, C, D if n plus 3 factorial and n plus 2 factorial equals that. Now just to remind you what factorial is, for example, 4 factorial would be 4 by 3 by 2 by 1. N factorial is n by n minus 1 by n minus 2 all the way down to 1. So n plus 3 factorial will be, and this is maybe difficult, it's not something we always see, but just bear with it. So n plus 3 factorial means n plus 3 multiplied by n plus 2 multiplied by n plus 1 multiplied by, well, I'm actually going to leave it there at n plus 1 factorial because then I'll be able to cancel with the 1 on the bottom. Now, and then that's n plus 2 factorial, so I'm going to have to multiply all of that by n plus 2 factorial, which is n plus 2 times n plus 1 factorial. And now if I look at this, this works out really well because I have n plus 1 factorial on the bottom times n plus 1 factorial. So that will allow me to cancel these out or to divide. So they will go and they will go. And that leaves me with n plus 3 times n plus 2 times n plus 2. this other n plus 2 here. And that's equal to an cubed plus bn squared plus cn plus d. Now I'm just going to multiply out the left hand side and then equate the coefficients. So I'll multiply these two together first. So n times n is n squared, n times 2 is 2n, 3 times n is 3n, and 3 times 2 is 6. Then when I'm done, I'm going to multiply that by n plus 2, and that just an cubed plus bn squared plus cn plus d. Now, so inside the brackets, 2n and 3n is 5n. So then that's n, multiply that by n plus 2. So n squared by n is n cubed. N squared by 2 is 2n. 5n by n is 5n squared. 5n by 2 is 10n, and 6 by n, 6n, and 6 by 2 is 12. Remembering that that's equal to an squared plus an cubed plus bn squared plus cn plus d. So the n cubeds add up to 1n cubed, n squareds, that should be 2n squared there. N squared by 2 is 2n squared. 5n squared, so 2n squared and 5n squared is 7n squared. Now the n's add up to 16n, and the digits add up to 12. And that's equal to an cubed plus bn squared plus cn plus d. So if the left-hand side is equal to the right-hand side, then a must be equal to the coefficient of n cubed, which is 1. bn squared, or the number of n squareds on the right, must be equal to the number of n squareds on the left, so therefore b is 7. And c must be 16, and the constant is 12.